Everybody ready to subnet? So let's talk about why subnetting is important for a second. Subnetting is important because you're going to see it in every other class you take that's not this one, basically. There's going to be some kind of subnetting problem. If you get into the Cisco courses, the exams, there's a large percentage of the exams that are subnetting. So that's why it's so important to understand that at this level, so that from now on when you see a subnetting problem, you'll be able to get it really quickly. And it won't be a problem. You can move on to something more difficult. So this week we're going to work with Class C subnetting. We're going to talk about subnetting, what it means, why on earth we would go to all the trouble to do it. There's not going to be any stuff that's going to be due during midterm, but when we come back from midterm, we're going to start A and B subnetting. It's the exact same principle. There's just a couple little things in it that make it distinctive. So this week we're just going to focus on Class C subnetting. So in Chapter 3 and 3.5 that we just went over in the last few weeks, we learned about defining and finding the valid host ranges for a Class A, B, and C network. We termed the host bits off and on. We talked about that. When we were talking about that, all that's good, but we're really still just defining only one network. We have not really segmented our network unless we put another switch in and then connected people to that switch. We didn't really do any segmentation of the network. So in this case, I've got usable number of hosts that's a .2 address all the way to a .132. But all these people are still placed in one big broadcast domain. So if we could, we would really prefer to break up those networks into one huge network address, create manageable networks from it, but to make that happen, we need subnetting to be able to do that. So that's the way we take a big network and we break it down into kind of chunks so that we can manage those networks. So when you look at this figure, this is what subnetting looks like. So we have 4 different addresses there, but you see the only thing that's different is the last octet. We've got a .0, .32, .64, and a .96. So this network has been subnetted. So the addresses within it are going to be different. So if we want to create a subnet, how do we do that? Well, first we have to determine the number of required network IDs. We talked about a network and a broadcast address. This is the same thing. So for network IDs, we need one for each subnet and one for each WAN. So one for each LAN subnet means that's the address that gets us outside of that segment. So like to the internet, generally, or maybe to another segment of the network. That's what the network address does. It gets us outside. The second thing we need is we need to figure out how many hosts are going to be on each subnet. That's a really huge deal because if we run out of hosts, we're going to have to do some serious reconfiguration of addresses to get more people on it. So we want to plan so that beforehand we know exactly how many people need to be on this subnet. So that's how many IP addresses do I need. And the third thing we need a subnet mask for the network, a subnet ID for the physical segment, and then a range of IDs that we can apply to the computers that are on each segment. So for example, at TSTC, they may have subnet masks that reach the whole campus. There might be specific ones just for the IT department. There might be specific ones just for this classroom. So subnets can be hierarchical as well. They can tell us, hey, all the computers in this room are connected to this subnet. All the computers in the next room over are connected to this subnet. So that's what we need to make a subnet. So speaking of subnet masks, we had talked about previously the default subnet mask for a Class A, B, and C address. We're not assigning D&E addresses, so we don't really care what their default subnet mask is. But basically everywhere you see the word network, there's a 255, and everywhere you see a node, there's a 0. That's how we determine the default subnet mask for those classes. So the subnet mask tells the computer which part of this address belongs to the network ID and which part of this address belongs to the host ID. That's the whole point of the subnet mask. So if it's got a 255, it's the network. If it's got a 0, it's the host. That's what the network address is telling anyone who goes and tries to use it. Now, I'm saying all this, and subnetting is very important, but not all networks need to be subnetted. So for example, if you have a small office with 15 people in it, and 15 computers, maybe 20 devices by the time you put in, a server, and you put in a couple printers, you don't really need to subnet 15 computers worth of stuff, or 15 addresses worth. This is more for a larger scale. So if your network isn't subnetted, you just put in the default subnet mask. That's all you have to do. Now, this is a screenshot of the ipconfig command from my computer that's going to show, hey, these are what IP settings have been done on your computer. This is what your IP settings are right now. So looking at that, how can I tell if my computer on the network is subnetted or not? Looking at the address in the subnet mask.
The address is a 10, which makes it a private.
Okay.
And then the 255, that's the subnet for IP.
Okay. It's the default for a B. But yeah, that's exactly what I'm talking about. So the default subnet mask for a class A 10 is a class A. So the default subnet mask for that is what? 255.0.0.0. But my subnet mask here is 255.255.0.0. So is my computer on a network that's subnetted? Yes, it is. Because it's not the default. It's something else. Right? So that's how we can look at IP configurations and see, is this on something that's subnetted or not? So when you get a block of addresses from your ISP, now for us just getting a business for a small address or for residential, we just get one address from the ISP because that's all we need. As we talked about before, our router handles the network address translation to make sure that all those things can work properly. But sometimes you would get a block of addresses from your ISP. Let's say that you host websites, and each one of these blocks is going to be an address that a website sits on a server and people can call up this website. So you get more than one address. There's lots of reasons why that could happen. But when you get a block of addresses from your ISP, it looks like this: 192.168.10.28/28 is how we refer to that. The /28 part of that is your CIDR. CIDR stands for Classless Interdomain Routing. All that is it's telling you how many bits are turned on in the subnet mask. It's a very large name for something that's very, very simple. So that is, when you see that /28, just think / how many bits are turned on in the subnet mask. So if I'm looking at an IP address, I've got 8 bits, a period, 8 bits, a period, 8 bits, a period, 8 bits, a period, right? How many bits are in each section? 8. So here, 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 and here. So a /24, all these bits would be turned on, all these bits would be turned on, all these bits would be turned on, because that's 24 bits worth. You're always starting at the left and moving right when we're talking about subnet mask. And that means there's 4 extra turned on here. So if I wrote this out, where my 28 bits are, my /28, I have 8, 16, 24, 25, 26, 27, 28. So my subnet mask that matches a /28, here's where we pull out our binary, would be 255.255.255. Dot what?
240.
240. And I got that 240 by adding 128, 64, 32, and 16, right? We went through and did our binary calculations. So, saying 192.168.10.28/28 and saying, hey, here's the IP address and the subnet mask is this, is saying the same thing. Anybody have any questions about how I just got that number? So let's talk about some default subnet masks and what their CIDRs look like. So our CIDR is that slash notation we just talked about. So in a class A, my subnet mask looks like 255 and then a bunch of zeros. So how many bits are turned on in a default class A subnet mask? 8. I could have said how many bytes are turned on and you told me what amount. But yeah, 8 bits, 1 byte, yeah, are turned on in a class A. So that makes the CIDR what? The CIDR's the slash. /8, exactly. Okay, with class B, my first 2 octets are 255s and everything else is a 0. How many bits are turned on? 16, which makes my CIDR /16, exactly. That should say C. Let's pretend it does. In a class C address, 255.255.255.0, how many bits are turned on? 24. My CIDR is /24, right? Seems easy enough. So, on the next slide, you're going to see, hey, here's a bunch of available subnet masks and what their CIDRs look like. So you can see all you're doing, you can kind of pick up the pattern as you go down, all you're doing is adding, you know the full ones are going to be 255s, and wherever it's not a full one, you're going to have to do some binary math to figure out what the subnet mask is. And that's all this is. So if I have 18 bits turned on, there's 8, 16, 2 left over, be 17, 18. So I would add 128, 64 to get 192. That's all that's happening here. That's the pattern. One of the things that we'll practice a lot with subnetting, but it's good to know if you don't already, is the powers of 2. There's lots of different ways to learn subnetting. There's many different ways you can do it. I'm going to teach the way of the book because that's the way that I learned it, and to me it's really easy, but my method relies on you knowing the powers of 2. But when you think about it, you start with 2 to the first equals 2, and every way up, every time you add a bit value on the side, you're just doubling the number. So you can double or halve to get whatever that power of 2 is. There's not going to be many instances, and not this week, we're not going to go past here. There's not going to be many instances in this class where you're going to have to know gigantic numbers, because we're just talking about the logic of subnetting. And I will allow you to use a calculator. By calculator, I mean the calculator on your computer, not on your phone, but you do have a resource. Any questions so far? Okay, so once you've figured out how many addresses you need, once you've figured out your subnet mask, then you can use a couple little formulas to figure out the number of hosts and the number of subnets. So this is kind of the crux of subnetting. This is what it's all about. So if my subnet mask, let's start with 192. Okay, so let's say this is my subnet mask, 255.255.255.192. If I want to figure out what that 192 means for me, when I subnet, what numbers do I get based on that subnet mask? This is what I do. Well, first off, I'm going to turn this into binary. So I'm looking at that last octet. So that's going to look like this. Right? Because 128.64 equals 192. So now I have my subnet mask and I have it in binary. I need to know how many subnets does that subnet mask give me. So the formula to that, now X and Y's I'm not crazy about. I like letters that mean something. So I'm going to say 2 to the S, because S equals, this helps us determine subnets. So as I say 2 to the S. 2 to the X, same thing. It's just a variable, right? So, S is going to be the number of bits that are turned on. So in what's turned on here, 2 to the second. I have 2 bits turned on because they're ones. 2 to the second gives me 4. So how many subnets does this subnet mask give me? 4. That's this right here. How many subnets does the chosen subnet mask produce? Now let's talk about hosts. Well, the hosts, I'm going to say 2 to the H minus 2. Where H is the number of bits off. So how many bits are turned off? 6. So 2 to the 6th minus 2. Now, why did I do minus 2?
For the network and broadcast.
For the network and broadcast. For every subnet, I have 2 addresses I cannot use. If it's asking for available hosts, I'm subtracting 2 every time because I can't use 2 of them. If it's asking for total hosts, I'm not. But for right now, we're going to talk about what's available. So what's 2 to the 6th minus 2?
62.
62. Okay, so in this configuration, I have 4 subnets. And I have 62 available hosts in each subnet. Later we will map that out and you'll get to actually see how that works. But for now, just trust me. Okay? So I have 4 subnets in a .192 and 62 available hosts on each subnet. Okay? As far as what the broadcast address is for each subnet, it's going to be the one right before the next subnet, and I'll do a demonstration of that in just a second. And what are the valid hosts on each subnet? That's the valid IPs, taking out the 2 that you can't use. So I have 64 total addresses on each subnet, but I can't use 2 of them. 2 of them are not available. That's where I get the 62.
Is it always minus 2?
If it's talking about available, yes, always. Okay? So does everybody see where I picked up, hey, these are the ones that are turned on to get our subnets. These are the ones that are turned off to get our hosts. Scott, can you see? Okay. I always worry about this column. Okay, well that's a big part of subnetting right there. So now let's do a full example of what this looks like. So in this example, we're going to use dot 128. So this is the first available Class C subnet. So when we map this out, how many bits do we have turned on? 1, which means 7 are off, right? So that's what my last octet looks like. So how many subnets do I have? That would be 2 to the S, 2. 2 to the first equals 2. And if I want to talk about my host, available hosts, 2 to the H minus 2, which is 2 to the 7th minus 2, 126. So with this configuration, I have 2 subnets and 126 hosts on each subnet. And if you need more of an explanation or you want to go back, this kind of talks it out a little bit more. But in this case, the math is kind of easy, right? So that, speaking, is also /25. So /25 because we have 24 bits turned on, then 1 more, and then everything else is turned off. So here's the thing about subnetting that it takes some people a long time to grasp. If you have a /25, this math is always the same. If you have a /25, you always have 2 subnets and 126 available hosts on each subnet. Always, every single time. We just did a /26. We had 4 subnets and 62 available hosts, right? Every single time you have a /26, that's exactly what you have. Every time. So, the only thing that changes is what your addresses look like. We'll get into that in a second. But that's the only thing that changes. This math of this binary and using the 2 to the S, 2 to the H minus 2, it always ends up the same. Okay, now if we wanted to subnet this out, this is what we would do. I use this method because this makes sense to me. If you have another way of plotting out your math, that's fine with me. I don't care. But this is what I do. I start with the subnet, or you could call it the network address. I have the first host, the last host, and the broadcast. So this list should be kind of short in this instance because I only have 2 subnets. So my first network address is always 0. 0 is always the first option in addressing. So I have 0. Now, this number right here, when you convert this to binary, this is your increment. So wherever that last 1 lies, that's called the increment value or the block size. So in this case, the binary value of the last place where the 1 stops is 128. So when I'll go to increment to my next network, I take this address and I add 128. What happens if I add 128 to that? I get 256. Is 256 a valid IP address? No, it's 1 too many, right? So look, I said I had 2 subnets, and I do. 1, 2. Okay? Now the previous slide I talked about, well, how do you find the broadcast address? The broadcast address is 1 less then the next one down. So this is my first subnet. This is my second subnet. If I'm trying to find the broadcast address on the first subnet, I want the address that comes before this one. So in this case, that's what? 127. Now I know these aren't addresses, we're just looking at the last octet right now, just to get started. Now this gets a little trickier here. What's going to be my broadcast address for the second subnet? 255. Why? 256 we can't do. So this is the last address. We've run out at that point. Now if we look, our first host is going to be the one that comes after the network address. So it's a 1. Our last host is going to be the one that comes before this one. Do I have 126? Didn't we say we had 126 available hosts? We had 128 total. This counts as 1, right? That counts as an address. So I have 0 to 127. That's 128 addresses. 2 of them I can't use. So I have 126 addresses total. That's just what our math told us earlier, right? Make sense? Okay, so if I'm going to do this at the bottom, well, 1 plus this one is 129. And 1 minus this one is 254. So if we're going to subnet a /25 network, we always get those numbers. Okay? Questions? So if I ask you what's the valid range of IP addresses in the second subnet, what would your answer be? 129 to 254. Those are the ones that are valid, usable addresses in the second subnet. And we'll do tons of problems like that. So that's the kind of stuff you can expect with subnetting. Now, if I want to denote, we're going to say, let's say the first usable address in the first subnet. If I really want to write out that whole address, I look at this network address up here. So these numbers we were putting up, these were the numbers that go in the last octet. So if I want to write that out, the first usable host, I know it's a 1, but my whole answer would be 192.168.10.1. Just to give you an idea of what they're asking for, what these questions kind of look like. Okay, so if we were to put this into practice in the real world. So in this case, we've got a business and we needed to separate the salespeople from the accounting people. Because the accounting people have access to payroll and stuff. It's really important that they be able to do their job so other people can get paid, right? So any tax stuff that needs to be done can be done. So when we take that chart that we just fixed, this right here, and we look at it, when we're plotting this out, we say, okay, well the first available host on sales is 1, then we've got 2, 3, 4, all the way to 126. That's the last available host. So these are the addresses that we're assigning to the computers in the sales group in this chart. Then we're taking the second subnet, we're starting with 129 because that's our first host in the second subnet, all the way down to 254 because that's the last available one. These are the addresses that we're assigning to the accounting part of business. So I have 2 subnets, I have sales and accounting, and I have enough addresses for 126 computers in the sales group and 126 addresses in the accounting group, and I'm keeping them separate. So why on earth would someone want to do that? So this is for separation, for security. Remember when we ran Wireshark and we just saw tons of ARP protocol, lots of broadcasting, people trying to figure out what's my place on the network, what's my address so that I can communicate. That also segments that down into manageable pieces. So if there is a problem on the network and suddenly some computer gets attacked, or something happens where a program starts trying to do a whole bunch of traffic, it doesn't affect the entire network, it affects this little section. And as a network administrator, I can go look through my traffic and figure out, okay, drill down to, okay, it's a sales problem, okay, it's this computer's problem, and go fix it. So that's what subnetting does for us. It's also for security purposes. So, for example, we have a cyber lab, or more than one, but we have a cyber lab here where they do a lot of infecting each other and trying to do ethical hacking and practices like that. We don't want them on the same subnet as us, because if they unleash something, like a virus, it could infect us, and then we wouldn't be able to use our computers. So there's a security example of why you would want to subnet a network. So if you have a network of 10 computers, they're talking, they're broadcasting back and forth. It's not very many people because it's just 10 computers. But now if you add 1,000, 10,000 computers, there's no separation between them. They're going to talk and talk all the time until they'll eventually bring the network down. And if something bad happens, which we'll talk about in future classes, it could just bring down everybody and everything, right? So that's one of the big reasons that we would subnet. Another reason is if you're an internet service provider, they're the people giving IP addresses to all of their customers. So they have to subnet their networks to give the right amount of addresses to the right people. Because we only have so many, right? We only have 16 million something, but it has to go throughout every single person all over the world. So they have to be careful about what addresses they're giving out and to who they're giving them out to. So that's one reason why they would need to subnet their addresses. Okay, so let's look again our /26. So if we have a /26, we've got a subnet mask of 192. When we convert that to binary, it's going to look like this. Because 128 plus 64 equals 192. So going by this chart, I need to fill in this chart. What's my first step?
Zero in the first one.
0 in the first one. How do I find my increment value? Whatever the binary value is of the place where the last one stops. So here's the place where the last one stops, which is what? 64. So this is my increment. 64. So what do I add to that? 64. Next. Yeah. 128. Then what? 192. Then what?
That's the last one.
192 is the last one. Yes. Because then we hit 256 again. So we've taken our increment value and we're starting with our initial 0 and adding 64 every time we go down. So didn't we say earlier that we had 2 to the 2, which was 4 subnets? 1, 2, 3, 4. Right? My broadcast address for the first subnet,
63.
63. 64 minus 1 is 3. My adding 1 to this one gives me the first available host on that subnet, and subtracting 1 from that gives me the last available. What's the broadcast address for the second subnet? 127. How about this one? 191. 255. So if I know that information, well, I can say, okay, that plus 1 is 65. This minus 1 is 126. This minus, or plus 1 is 129. 191 minus 1 is 190. Gives us 193 and 254. So just to check, our host is 2 to the 6th minus 2, which gives us 62 available hosts. 1 to 62, 62 to 126, etc. So all that math checks out, which means we did it right. Any questions on that? This side of the room is on it, this side of the room, crickets. So come on. Roderick, I'm looking at you. Come on. All right. So similarly for a /27, so if I have a /27, then I have 24 bits turned on here, 3 turned on here, and everything else will be zeros, which means my increment value is going to shift over. Now what's my increment size going to be? 32. So if I start with 0, as you can see over here, and I increment by 32 every time, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8 subnets, which is good because 2 to the 3rd equals 8. Right? So I'm not going to go through and do every one, but you can see that if the next subnet starts with 32, 1 minus that is 31. So that's going to give us our broadcast for that, which means our first address is going to be 1 and the last one's going to be 30, which also makes sense because 2 to the 5th minus 2 is 30. So you can see this pattern emerging, hopefully. See this math coming up every time? If you're to do a /28, you see that subnet mask changes. So our increment's going to change again because now I moved my 1. 192 plus 64 plus 32 plus 16 equals 240. So my binary changed again, which means my subnet's going to change, my hosts are going to change. So my increment turns into what? 16. Okay? So now I can start 0, 16, 32, 48. Hmm? 64. 80. 96. 1.
It's 86.
64, 80, 96. 16 plus that's 112.
112.
Need more room now, right? Plus 16 is 128. Plus 16 is 140. No.
Yes.
144. So I'm only halfway through. But there's about half of my subnets. Right now I've run out of room. Because my increment changed, right? My increment is smaller now, so I have more subnets to deal with. Right? The same principle applies, but as I keep pushing that subnet mask and making it higher, my subnets start getting smaller and smaller and smaller. So if we were to do a /29, well now we're adding another 1. So now my increment's 8, so now they're even smaller. So my number of subnets there would be 2 to the 5th, which is what? 64. So I have 64 subnets with 2 to the 3rd, 8 hosts, or no, 6, excuse me. 6 hosts. So now you see the relation, you kind of see what's happening here. And in the book, they detail every single piece of this. So if you have trouble understanding where that math is coming from, you can. For a /29, here we keep adding another bit. We see that our subnets, now we're down to 8 as an increment value. If we go to a 30, we're down to 4 as an increment value. So you see, that's not everything, but that's a little bit about. You can see your first, last, and broadcast hosts. If your subnet's only 4 addresses big, only 2 of them can be used because one's the network address and one's a broadcast address. So now they're teeny tiny. So if you look on page 156 of your book, there's a section, What Do We Know? So this is just detailing, okay, so for a /25, the mask is this, how many bits are on, how many bits are off, what are the subnets, and then how many hosts are in each subnet. So what can you tell me about the relationship between subnets and hosts? The more subnets, the fewer hosts. That's it. So as the number of subnets increases, the number of hosts decrease. And as the number of hosts increases, subnets decrease. So there's an inverse relationship here. We only have 8 bits to work with, right? If you have less of one, you're going to have more of the other, right? So that's what I want y'all to understand about subnetting. Y'all all seem to grasp that pretty well. So are there any questions about this? No? It's just math. Everybody talks about how intimidating it is, how difficult it is. It's just math. It's fine, right? If you understand your binary and you can do powers of 2 and you can add, you're fine, right? Okay. Okay, so as far as assignments today, we're going to do Written Lab 4.1. So, just to clarify, Written Lab 4.1 starts on page 171 of your book. There's 5 questions on the front. If you flip to the second page, there's 5 more questions. as far as what I want you to turn in, I don't care if it's on paper, I don't care if it's typed, I don't care how you do it, whatever way is easiest for you. But here's what I'm expecting. So for questions 1 through 6, just to give you an idea of what it is, write the subnet, broadcast address, and valid host range for question 1 through question 6, then answer the remaining questions. So the rest of them are just questions about what we talked about, but the first 6 require you to subnet. Now we've gone over those examples in class, but what I want you to give me is, okay, for example, the first one is 192.168.100.25/30. So that's going to be the first part of the question, right? Then you're going to tell me, okay, this is what that bit value looks like as a subnet mask. This is what the increment is, that magic number where the last one is. The valid subnet, the broadcast subnet, and the valid host go between this and this. That's what I want you to tell me. There's a couple other hints about, because the questions are kind of general, what I'm looking for in the other ones, whether it should be a CIDR, it should be the broadcast address that it's talking about, it should be the subnet address, and you'll get more of a feel for that once you look at the questions. But that is your assignment for today, to go over subnetting. When we come in on Wednesday, we're going to watch an example video of someone subnetting that I think is really helpful, and then we'll go through some more problems. Okay? And if you have any questions, I'll be walking around, so just let me know.